Hey programmers, Alvin here. Right now I want to go over a JavaScript solution for this sum list problem. So I think we'll get things kicked off by implementing a iterative version for this. So I know I want to create a sum and add to it over time, so I'll create that variable. I'll say let sum equal 0. I know by the end of this function, I'm just going to return that total sum. Now I need to lay down my very standard code for just traversing through a linked list. So I'll say let current. I'm going to keep updating this variable over time, and it's going to initialize with simply the head node. And I know that in the loop for this kind of classic linked list traversal, I just want to iterate while current is not equal to null, right? If it's not equal to null, then it's a node, so I can actually look to its next pointer. So I know I'm going to need this pattern, right? Set current equal to current dot next. This actually steps through, the linked list in sequence. But how do I actually want to utilize my current node's value? Well, I just want to take it and add it into the sum, right? So sum plus equals current dot val. And eventually, once I hit the very, very end of the linked list, I know current is going to be equal to null, so I exit the while loop, and I'll just return my total sum. So let's run this. Just a little variation off of our last problem, just doing some computation along the way. Nice, and now I think I'll show you the recursive version, which I quite like. So for your recursive version, it's all about starting with a meaningful base case, right? So the first thing to think about is, all right, typically for my linked list problems, my base case is about my head being null, right? And that kind of represents the scenario where my linked list is an empty linked list, right? If it's null, it means it has no nodes. So what's the total sum of an empty linked list? Well, it's just 0. So I'll check if head is equal to null, then just return 0. And it's important that I think about compatible types here. I know when my linked list actually contains some nodes, then I should return a number. And even in the base case, I should return a number. It's just the case that I return the number 0. Nice. Let's say now we write our recursive code, right? If the head is not null, then it's actually a node. So I can look at its value, right? I could say head.val. And what I want to do is take that number and add it to the sum of the remaining nodes in the linked list. How can I get the sum of the remaining nodes after my current position? Well, that's just about calling your function recursively, right? And passing along head.next, right? So always try to think about your recursive call for the type of data that it returns, right? It gives me back a number representing the total sum of everything starting at the next node. I'll take that number, add it to my value. That should give me my complete sum. So I'll just return it. So I'll give this a shot. And the recursive code is quite short. One thing we should consider, though, when it comes to like an apples-to-apples comparison between the recursive and the iterative, they both have the same runtime, right? They both have O of n. In the case of my recursion, I have n calls. In the case of my iterative code, I have n just iterations in the while loop. But the recursive version also uses n space, right? That's because for recursion, we actually have to add every function call onto the call stack. So I know by the time that my recursion bottoms out at a base case, I would have n calls on the call stack. Whereas in the case of our iterative code, we would actually use only a constant amount of space because I only use a handful of variables here. That being said, I highly recommend that you practice both of these solutions because depending on the problems that we solve, you may find one more natural to use than the other. So with that, practice this and I'll catch you in the next one.